Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 34, Types of Chemical Reactions, Part 9. This is the last video in Chapter 4. Here are our objectives for today's video. Pause here. So in this video, we're going to focus on a way of balancing chemical equations that not only balances the individual atoms, but also balances the electrons that are transferred. So I have here an example, the same single replacement reaction we looked at in an earlier video, and I've broken it into two separate parts. First, the oxidation, and then the reduction. I'm going to walk you through how to do this, but what I want for you to notice right away is the first thing is I didn't include what's called the spectator ions here. The NO3 was aqueous on both sides. I did not include it. It wouldn't necessarily be wrong to include it, but I prefer not to. The second thing that's a little bit more interesting, you haven't really seen before, is that in the oxidation, we see that the electron is a product, and in the reduction, we see that the electron is a reactant. Pause here. So with balancing redox reactions, in addition to balancing out the atoms, we're going to need to balance out the electrons as well. We're going to do that by splitting the reaction into its oxidation and its reduction, and then ensuring that we've got equal numbers of electrons in both before putting it back together. Pause here. So first I'm going to need to decide what is oxidized and what is reduced. So I'm looking here for something with that is giving away electrons. So it's going to be the iron here. When you're doing the half reactions, you can leave out the states. I don't have an issue with it. So iron is becoming iron 2 plus, and in the process of doing so, it is losing 2 electrons. So those electrons are a product. We are losing them. As opposed to the reduction, we've got silver with a +1 charge that is becoming regular silver. And this has to gain an electron in order to do that. So notice with the oxidation, I've got 2 electrons, and the reduction, I have only 1 electron. So what I have to do is I take my reduction reaction and I multiply both sides of it by 2 to balance out the electrons. So in my balanced chemical equation, all I have to do is put a 2 in front of Ag plus and a 2 in front of Ag, and this is balanced. Let's take a look at another example with this. This one is very, very similar. You'll notice that a lot of these will have the sort of pattern where we don't really have a whole lot of compounds going on. That is for a reason, just because most reactions of the sort are fairly simple. So for the oxidation, this is nickel. So it's going from a 0 charge to a +2 charge, so it is losing 2 electrons. So those are going to be the oxidized, the part of the product. And then for the reduction, going from cobalt with a 3+ charge to cobalt with a 2+ charge, and in order to do so, this needs to gain an electron. Similar to the last problem, the whole reaction has to be multiplied by 2 in order to balance out the electrons. So I put a 2 here and a 2 here in order to balance it out. One more example, this one is a little bit trickier. So what makes this one trickier is the fact that O2 on the left is covalently bonded. You cannot break things apart that are covalently bonded when you're writing the half reactions. So here it's reduced. I'll do the oxidation first. So aluminum is going from a 0 oxidation state to an oxidation state of +3. And it's going to lose 3 electrons in the process. Notice how I left it as Al3 plus in the end. The reason why I did that is because Al2O3 is a ionically bonded substance. So for things that are ionically bonded, you don't have to, well, it's actually incorrect to keep them together for these half reactions. But in the case of oxygen, I have to keep O2 together in the reactant. which means that I have to have two oxygens on my right side just to balance it out before I even get to the electrons. So from here, I've got two oxygen atoms, each of them gaining two electrons. So I have four electrons. So what that means is I have to take this whole reaction here, multiply it by 4. This whole reaction here, multiply it by 3, and then use this to balance my equation. Notice how I put the 2 there? That's so I still get my 4 aluminums. 2 times 2 is 4. 2 times 3 is 6. I still have my 6 oxygens. This will be the focus of our in-class practice if this is still a little bit hazy to you. So if you got the first two and then the third one's a little bit hazy, this is really what we'll be focusing on. But I don't want this video to go on forever, so I'm going to stop myself here. Thank you so much for watching and have a great night.